Welcome back. I'm going to continue with 5 through 9 here, the solutions to that practice exam. So number 5 here is just a polynomial with a bunch of terms that we'll use the power rule to get the derivative. It won't be that difficult. So I'm just going to do number 5 right here. And we'll do each term one at a time, right? We'll use our sum and difference rules for that. So remember that 3 here on this term is a constant multiple. And when we bring the 5/3 down and do 3 times 5/3, we get 5. And then you subtract 1 from that exponent. And so that will be 5/3 minus 1, which is 5/3 minus 3/3, which is 2/3. For the next term, we are going to bring the 5/2 down and multiply it by 2/5. And that turns into a 1. So I don't have to worry about that. And then I'm going to subtract 1 from 5/2, and that would be 3/2. It's 3 over 2. The next term, we bring the 2 down. That makes 3 times 2 is 6. And then the x to the first power. And then finally, the derivative of just 6 on its own is 0. So I won't write that one down. So our derivative for number 5 is just 5x to the 2/3 plus x to the 3/2 minus 6x. For problem 6, we've got a little extra work to do first here. So we're given this little expression, but it's written with fractions, right? With rational functions. So I mean, I guess we could go through this one at a time and do the quotient rule on each one, but that is a lot of work. What I recommend instead is my little hint here where I said, hey, let's change these to powers first, powers of x. So that's what I'm going to do. So when I do number 6, first I'm going to transform each term into a power of x, meaning I'm going to move that x to the 5th or x to the, what is that, x squared, or that x up with the coefficient using negative exponents. What I mean by that is this. The original function can be written as 2x to the negative 5 instead of 2 over x to the 5th, plus 3x to the negative 2 instead of 3 over x squared, minus 6x to the negative 1 instead of 6 over x. Okay, so we've transformed this function. We haven't done the derivative yet, just turned it into something we can work with. For the derivative now, we'll just use our power rule. So I bring the negative 5 down, times the 2, that's negative 10. Be careful with your subtraction. Negative 5 minus 1 is negative 6. Bring the negative 2 down, times the 3, that's negative 6. And then negative 2 minus 1 is negative 3. Bring the negative 1 down, times the negative 6, that's plus 6. And then negative 1 minus 1 is negative 2. So if you make it to there, you've done great, okay? Typically with problems like this, if it's written with fractions and positive exponents in the question, we'd like you to rewrite it in that same form. So what we're usually looking for on a problem like this, let me change this to blue. Instead of negative 10 x to the negative 6, the negative 10 stays in the numerator and the x to the negative 6 goes to the denominator. Instead of negative 6 x to the negative 3, it's minus 6 over x cubed. And instead of plus 6 to the negative 2, it's plus 6 over x squared. And that's typically what we're looking for. So for a problem like this on your exam, if you see one, try to get to the green for sure, but then transform it so that it has positive exponents on those powers of x. And write it as fractions here. And we do that when the problem is written this way to begin with. So try and mimic the form of the question when you write your answer. Okay, problem 7, find the equation of a tangent line. So now we're going to be doing several things here. We need the derivative, but that's not our main goal. Our main goal is to get the equation of a tangent line. So just to remind you that a tangent line is a linear equation, and typically what we're shooting for is to use the point slope form and fill in these three blanks. So we're trying to do y minus y1, and we're going to fill in that y1 box. There's good news in that in a minute here, but equals m, which is our slope. We're going to try and fill in that slope box, and then times x minus x1. And we're going to try and fill in that x1 box. So this is a fill-in-the-blank situation. To get the linear equation, I need an answer, or a number here, I need a number here, and I need a number here. So here's the good news. Two of those numbers are already given to us right here. The 0.05. The 0 is the x1, and the 5 is the y1. So I am 2/3 of the way done. What I don't have is the slope. The slope is going to be the value of the derivative at the point 0. I need to find f prime of 0. So my derivative for this function is, bring the 2 down, that'd be a -1x minus 3, and then plus 0 for the 4. And so when I plug 0 into this function, I get -1 times 0, which is 0, minus 3. So my slope is -3. Okay, so for the equation of the tangent line, it'd be y minus 5 equals -3 times x minus 0. And that is the equation. So you're okay if you make it to there. Oops. Right? This is one form of the final answer. It's typically not the way we write that, though. What we usually want to do is put it in some sort of a slope-intercept form. So I'll just simplify this a little. This is going to be y minus 5 equals -3x, because x minus 0 is just x. And then when you add 5 to both sides, you get the more familiar form for an equation of a line, which is y equals -3x. No, don't solve. X plus 5. And that is the typical form for this answer that we're shooting for. So when you're asked to find that equation of a tangent line, don't forget you're really just trying to fill in these three blanks, y1, m, and x1. Sometimes x1 and y1 are given like they were here. That's excellent. But you still have to go and get the slope. And the way you find the slope is you find the derivative and you plug in the x-coordinate. And that's what we did. Okay, now for number 8, we have to use the product rule to find the derivative of this product of these two expressions. And I'm going to have to move to another space here. Let's do it right here in the open space. My original function is f of x equals 3x plus 4 and 2x minus 5. And there's different ways to attack this thing, but essentially we just want to run through the product rule. The short version of the product rule that I usually use for students is the first function, 3x plus 4, I just call that u. And the second function, 2x minus 5, I call that v. And then I get organized. U equals 3x plus 4, and v equals 2x minus 5. And then my derivative for the u part is just 3, and my derivative for the v part is 2. And then to get the derivative, the form that I'm going to follow is just u v prime plus vu prime. That's the same as saying f of x times g prime of x plus g of x times f prime of x, right? It's the power rule here. So this thing here is just called the power rule. So for us, our answer is going to be 3x plus 4. That's my u. Let's do this in color. I'll match the colors up. 3x plus 4, that's the u, and the v prime is 2, plus the v is 2x plus 5, and the u prime is 3. So there's one version of the answer, but we do want to simplify this thing. We've done the calculus, now let's clean up the algebra. So I'm going to distribute the 2, that makes 6x plus 8, right? I just did 2 here, 2 here, and I'll distribute the 3, and that gives me 6x plus 15, and then I had to do a little math here. What is this? 6x plus 6x is 12x, 8 plus 15, did I miss a minus sign here? Oh my goodness, sorry about that. Let's go back and change this to a minus. Oops. This is 2x minus 5, right? See it right here? And that means this is a minus sign. And then I have to do 8 minus, oh, come on. I'm doing awesome in this video. Positive 8 minus 15, that's going to be minus 7. Okay, so it took me a minute there to get my signs correct. It happens. Please double check your work as you're going through these problems. But using the product rule, oh my goodness, I'm just having a moment here. All I want to do is this. Using the product rule, we were able to get down to our derivative, which is 12x minus 7. When you do this problem on your exam, I'm going to want to see the work, right? I want to see you actually use the product rule. So don't just multiply this function out and then use the power rule. Go ahead and run through the product rule. The instructions say use the power rule. Number 9, which is the last one for this video. Sorry about that. We're going to use the quotient rule to find the derivative of this function. And I'll just scroll down here and put that on the screen here. I'll rewrite the problem so we can see it. All right, so for number 9, the original function was f of x is x to the 4th minus 3 over x squared plus 3. And we have a quotient rule, which is essentially, g prime of x times f prime of x, or times f of x minus f prime of x times g of x over g of x squared. I usually simplify that by identifying the top function as u and the bottom function as v, and then I get organized. So if u is x to the 4th minus 3, u prime is 4x cubed. And if v is x squared plus 3, and v prime is 2x. All right, and then we put all the pieces in position following that quotient rule. So in the numerator, we're going to have v, which is x squared plus 3, times u prime, which is 4x cubed. Then we have a minus sign. That minus is a big deal, right? We don't want to commute those. You can't commute subtraction. Then we're going to have uv prime. So we're going to have u, which is x to the 4th plus, or minus 3, sorry. Oh, come on. And then v prime is 2x. And we have our fraction, and our denominator is just the v thing, x squared plus 3, and we square that. So I filled in the pieces for the quotient rule. Now it's just a matter of simplifying using algebra. So we're going to distribute and then combine like terms. So on the numerator, when I distribute, I get 4x to the 5th plus 12x cubed minus 2x to the 5th. You have to distribute the negative sign and the 2x. So that's going to be plus 6x. In the denominator, I'm not going to expand that thing. Just leave it factored. The less algebra, the better. But we are going to combine our like terms here. So do you agree that I have a 4x to the 5th minus a 2x to the 5th? So I'm going to combine those, and then we'll be done with this thing. Oops. So this is going to be 2x to the 5th plus 12x cubed minus plus 6x, sorry, over, oh, that's a terrible vinculum, but we'll count it, x squared plus 3 squared. That looks good. All right. Whew. Had a rough go during this video, but I think we've got these solutions now. Let's see if we can highlight this a little bit. So that's the form we're shooting for that particular problem. I'm going to just zoom out here so we can see the big picture of the problems that we worked on. So we went through 5 and 6, where we were just doing power rule stuff. 7, we found the equation of the tangent line, and then 8 and 9, we used the quotient rule for number 9 and the product rule for number 8. I'm just going to label this quotient rule so we have that in our notes. Okay, that's it for this video. I'll do another section of the practice exam in the next one. Take care.